In this video, we'll go over the homework that follows the lecture on areas in polar coordinates. And as always, I hope that you watched the lecture. And let's go ahead and jump right into the homework. So the first problem that we have is we are given a polar curve. And we are given, actually we have two polar curves here. And one of them is a circle with the center on the x-axis. So one of them looks like this. And the other one is the circle with the center in the origin. So it looks like this. Imagine if that was a circle. And now we're looking for the area inside the region, inside of this circle, but outside of the r equals 11 circle. So we're talking about this region right over here. And to find this area, the first step we have to do is we have to find the points of intersection. So we need to figure out the limits of integration, and for that we're going to set so this is pretty much where the two curves are equal to one another. So we're going to take the first curve and set it equal to the second curve, and we need to solve for theta. So cosine theta will be equal to, looks like it will be square root of 3 over 2. And that means theta will be ranging between, it's going to be pi over 3 actually that's not, cosine of theta is equal to, it's going to be pi over 6 and negative pi over 6. So again, the picture, and this is just me drawing it by hand. We can always just use Desmos to draw that. So r equals 11, that's this circle, and r equals 22 square root of 3 cosine theta all divided by 3, it's that one. And we can see that they intersect at negative pi over 6 and pi over 6. Now we're going to use this formula. The area between two curves can be found by setting up this integral. So R1 will be the outer one, R2 will be the inner one, and in this case it's going to be the integral from negative pi over 6 to pi over 6, 1/2 r1 squared. So the outer one is the one with the center on the x-axis. So it's going to be 22 square root of 3 cosine theta over 3 squared minus r1, or rather the other one squared, so it's going to be just 11 squared. And we have to enter the exact answer, so that means we have to integrate it. So let's go ahead and integrate it. We have 1/2 integral from negative pi over 6 to pi over 6. Here we have 22 squared over 3 cosine squared theta minus 11 squared d theta. we're going to technically we should be able to do this by hand. So by using the reduction of power formula here, so instead of cosine squared theta, we can write it's going to be what? Cosine of going to be cosine of 2 theta plus 1 over 2. So let's see what's going to happen there. Have 1/2. So we have 22. So 22 squared over 3. And here we're going to write cosine of 2 theta plus 1 over 2. Minus 11 squared d theta, simplifying this further. So I'm going to distribute 22 squared, so 22 squared is, it's 11 squared times 4, but that 4 divided by 2 is just 2. 3, so we have that many cosine of 2 theta plus just that many 2/3 of 11 squared, and then we subtract 11 squared. So this all just becomes minus 11 squared times 1/3, which is just this d theta, and now we'll do this separately. So the first integral becomes 11 squared times 2 over 3 times 1/2 sine of 2 theta. And the second one becomes 11 squared over 3 theta. And we go from negative pi over 6 to pi over 6. So when we plug in pi over 6, we get sine of pi over 3 minus sine of negative pi over 3. And here we have 11 squared over 3 pi over 6 minus negative pi over 6. And now we need to simplify. So we have 1/2 11 squared over 3. Sine of pi over 3 is root 3 over 2 minus negative root 3 over 2, so it just becomes root 3 minus, we're distributing the 1/2 over here. So I have 11 squared over 3. Pi over 6 minus negative pi over 6 is just pi over 3. And I think we're ready to write the answer. It's just going to be 1/2 11 squared over 3 times square root of 3 minus pi over 3. And again, I'm not going to risk it. I'm going to type this integral in Desmos. So that's the answer, and I'm also going to type this answer to see if it's the right one. So we have 1/2 times 11 squared over 3 times square root of 3 minus pi over 3, and it is the right answer. So I feel more comfortable now entering this expression. So we have 121 over 6, and here we have square root of 3 minus pi over 3. This was literally problem number 1. So let's continue. We have to find the points of intersection, and the first curve is 8 sine theta plus 2, and the second curve is 4 sine theta, and we're looking on the interval from 0 to 2 pi, so we're going to set them equal to one another. So 8 sine theta plus 2 is equal to 4 sine theta. Solving it for theta means we isolate sine theta, so subtract 4 sine theta from both sides, subtract 2 from both sides, divide both sides by 4, and now we can solve for theta. Theta will be arc sine of -1/2 plus 2 pi k, and the other value will be pi minus arc sine of -1/2 plus 2 pi k. So this is how we solve it in trigonometry. Now arc sine of -1/2 is -pi over 6, and our theta values have to be between 0 and 2 pi, so we're going to add 2 pi here. And for the second one, it will be pi minus -pi over 6, and that will be within the required restricted domain. So final answer is 11 pi over 6 and 7 pi over 6. So I'm going to type 7 pi over 6, comma, 11 pi over 6. And Newton is not great at solving trigonometric equations, so follow the method that I proposed. Alright, determine a definite integral that represents the area of the region enclosed by r equals 10. Again, the formula that we're using is integral from alpha to beta of 1/2 r squared d theta, and this integral represents this area. So we have some polar curve, and this is the area of a sector between alpha and beta. This is the area, like a slice. So in our case, it's just going to be an integral from 0 to 2 pi of 1/2 10 squared d theta. So this is 0, this is 2 pi, and this is simply 1/2 of 10 squared is just 50. Another similar problem. We're going to have an integral from alpha to beta of 1/2 r squared d theta. And in our case, alpha is 0, beta is 2 pi, and r is just 4 minus cosine theta squared d theta. So that's the integral. Normally we would plug it into Wolfram alpha or Desmos. In this case, we just type the answer. So 1/2 something squared and that something is 4 minus cosine theta. I should have read the question. It says, determine a definite integral that represents the area of the region in the fourth quadrant. So the fourth quadrant means we're integrating from 3 pi over 2 to 2 pi. That's what that means. So let's change that. So I have 3 pi over 2. But everything else is correct. All right, problem number 5. We have to set up the integral from alpha to beta of 1/2 r squared d theta, and here we have inner loop, so we need to figure out where does that inner loop happen. So we need to find out the alpha and beta. For that, we're going to set this equal to 0, and then cosine theta is equal to negative 1/2. So theta is equal to arc cosine of negative 1/2 plus 2 pi k, or theta is equal to negative arc cosine of negative 1/2 plus 2 pi k, and arc cosine of negative 1/2 is just arc cosine of negative 1/2 is what is it, 2 pi over 3? So theta is 2 pi over 3 or negative 2 pi over 3. And let's graph this just to see what's going on here. So the graph of this will be 24 cosine theta plus 12. That's the graph. Now we need to find the area of the inner loop. So here's what we're going to do. We're going to play with this. Let's do negative 2 pi over 3 and 2 pi over 3. So that's the outer loop. But if you go from 2 pi over 3 to what's the negative 2 pi over 3? What would be the equivalent of negative 2 pi over 3? 4 pi over 3? Oops. So that's the inner loop. So that pretty much tells you the limits of integration. We're going to integrate, to find the area, we're going to integrate between 2 pi over 3 and 4 pi over 3, and we're going to integrate 1/2 r squared, and r squared is 24 cosine theta plus 12 squared d theta. So this is our integral, and we're going to simplify a little bit. So we're going to take out 12. So it's going to come out as 12 squared. Now, what do we have inside? We have cosine two cosine theta plus 1 Okay, let's see if we have to do it by hand. Enter the exact answer. So once we took the 12 squared over 2 out, we have 2 cosine theta, so it's 4 cosine squared theta plus 4 cosine theta plus 1 d theta. Now, instead of cosine squared theta, we're going to use the reduction of power formula. So it's going to be cosine of 2 theta is, so it's going to be 1 plus cosine of 2 theta over 2. And we're going to continue. So 12 squared is 144. 144 divided by 2 is 72. So I have 72 integral from 2 pi over 3, 4 pi over 3. Here we have 4 times that, so 2 is gone, so we have 2 times 1 plus cosine 2 theta plus 4 cosine theta plus 1. Now simplify real quick. So we have 2 cosine 2 theta plus 4 cosine theta, and we have plus 1 plus another 2, so we have plus 3 d theta. Now we're going to integrate. So we have 72. We have sine of 2 theta plus 4 sine of theta plus 3 theta from 2 pi over 3 to 4 pi over 3. And plugging everything in, we have sine of 8 pi over 3 minus sine of 4 pi over 3 plus 4 sine of 4 pi over 3 minus sine of 2 pi over 3 and plus 3 times 4 pi over 3 minus 2 pi over 3. And now let's simplify. Sine of 8 pi over 3 is the same as sine of 2 pi over 3. It's the same as root 3 over 2. Sine of 4 pi over 3, it's negative root 3 over 2. So that's the first one. Plus 4. Sine of 4 pi over 3, again, is negative root 3 over 2. Sine of 2 pi over 3, it's root 3 over 2. We got that. Plus 3 times 2 pi over 3. And we're almost there. So we have root 3 minus 4 root 3 plus 2 pi. So 72 times 2 pi minus 3 rad 3. And again, I'm not going to risk it. I'm going to just plug it into Desmos to see if that's actually the right answer. So I have integral from 2 pi over 3 to 4 pi over 3 of 1/2 something squared d theta. Actually, just theta here. And inside parentheses we have 24 cosine theta plus 12. So that's the answer, and now I'm going to enter my answer to see if it's the right answer. 72 times 2 pi minus 3 square root of 3. And it looks like it's the right answer. So I'm just gonna try to copy and paste this into here. And it works just fine. And we finished the homework. If you have any questions about finding the areas in polar coordinates, please let me know.